All right, guys, we are on day 6 notes of Unit 5, and we're talking about exponential functions. So I think probably you've heard of exponential growth and exponential decay, and those are what we're going to be looking at today. So in number 1, it says, given the function y equals 2 to the x, fill in the table below and sketch the graph on the grid. So all we're going to do is we're going to go to y equals in our calculator. If you got something in there, clear it out. And we're going to go ahead and type in 2 caret x. Okay, so 2 to the x. And then we can go second graph, and we can go right to our table, and they've set us up a table already, and they want to know what goes with negative 3. And it is the decimal of 0.125, which is the same thing as 1/8 if you math fract it. Okay, negative 2 goes with 0.25, which is a fraction of 1/4. Negative 1 goes with 0.5, which is a fraction of 1/2. Okay, 0 goes with 1. 1 goes with 2. 2 goes with 4. And 3 goes with 8. All right, and then we're going to go ahead and graph that. So be careful with negative 3 and just up a tiny little bit. All right, we're going to talk that these exponential graphs actually will never hit your x-axis unless there's a shift on them or a translation. Okay, negative 2 and up a fourth. Okay, negative 1.5. 0 and 1, and now they get a little bit easier to graph. 3, 1, 2, 3, 4, 5, 6, 7, 8. All right, and so hopefully you guys can see that this is what they call exponential growth. Right? Try to go with a smooth line there. Hard for me on my slippery screen. But arrows at the top because it actually keeps going. Okay? And arrow down here too because it actually keeps going. Okay? All right, so that was the best I could do there with a smooth curve. All right, and we got some graph features we have to talk about. It says that this graph would be called an exponential growth. Okay. The graph is increasing from left to right. So as you read it from left to right, you're going up, or you can see that the graph is increasing. Okay. We're going to talk about A numbers, B numbers. Okay. When we talk about exponentials, they have a form of y equals ab to the x. Okay. Just like linear equations are y equals mx plus b, and the m stands for slope and the b stands for y-intercept, exponentials have an a and a b, and their a value is actually the y-intercept. Okay, whereas when we talk about linears, y equals mx plus b, their b is their y-intercept, but in this one, their a is their y-intercept. Okay, and what they call the b number is they call that the base. This base is actually known as your multiplier as well, okay, which we'll talk about in a second. So in this one, our a value, our a number is actually, our y-intercept is 1. And if we go back up here and we give this equation a look of y equals ab to the x, I could rewrite this so that that's y equals 1 times 2 to the x. And now you can see that this is my a value and this is my b value. Okay, but with that 1 being there, you don't really need to multiply 2 to the x by 1 because that's just 2 to the x. And so that's why you don't see that y-intercept in the equation. Okay. And then our b value will be the number that is our base, or the number that's raised to the exponent of x, which is our 2. Okay, and hopefully you guys can see that why there is a multiplier of 2, or why it can be called a multiplier. If you take a look from 1 to 2, you're multiplying by 2. Okay? 2 to 4, you're multiplying by 2. 4 to 8, you're multiplying by 2, okay? And in fact, that pattern continues with the fractions too. Just not sure if you can see it as easily with the whole numbers as you can with the fractions. Okay, but there is your multiplier. All right. So they also talk about domain and range, and domain is all the way to the left, which it keeps going. So we're going to say negative infinity, and as it goes up, it is still going towards the right, which is positive infinity. So we can go ahead and say negative infinity to positive infinity, or we could also say all reals. Okay. For our range, the lowest it goes looks like the x-axis, which is 0, and the highest it goes, it keeps going up, which is positive infinity. So we're going to go ahead and say 0 to infinity. But there's one thing we got to talk about, the 0. Okay, we actually are never going to reach 0 if you keep thinking about it. I always like to describe this as eating half my sandwich for lunch. All right, if I start with a sandwich and I eat half of it, I will have half left. If the next day I eat half of what was left, I have a fourth. If I eat half of a fourth on the next day, I'll have an eighth. If I eat half of what's left then, I'll have 1/16 left. If I eat half of what's left on the next day, I'll have 1/32. And I will never, ever, ever eat my whole sandwich. There'll be microscopic crumbs left, but if you keep going with the pattern, you're going to see that you will not ever eat your whole sandwich, which is kind of a weird phenomenon. So with exponential functions, we will actually never reach 0. And so because we're not going to reach 0, we don't want to include 0, and therefore 0 in our range will always get a round parenthesis. Okay. The x-axis, guys, actually has a name, and they call it an asymptote. Okay? Asymptote. That's how you say it. But it's a line that the graph of the function approaches but does not touch because of a specific error. And so that line is actually our x-axis in this one. So this is our asymptote. Our x-axis is the line that we're actually never going to, that our graph will never touch. Okay. And the reason that is that if we wanted our y value to become 0, and this is our equation, right? Y equals 2 to the x. If we want our y to become 0, what would x have to be in order for that to happen? And there isn't anything. You can raise 2 in order to get this to be 0. And because there's nothing we can fill in for x to give us 0, then this can never be 0, okay, for our y value. All right? Our x can be 0, but our y value can never be 0. And so that's the specific error that it can't have. All right. So coming down here, it says determine the equation of any asymptotes. And we do have that one asymptote. We have our x-axis. However, the x-axis is not an equation. And so we have to remember that the x-axis is our asymptote, first off, and that the x-axis is a horizontal line, also known as HOI, to help you remember that horizontal lines, their equations are y equals a number. Okay, and in this case, our y equals a number would be y equals 0. And there is the equation of our asymptote. Okay, if you were to graph y equals 0, it would trace right over your x-axis in your calculator. Okay. All right, so number 2, we're going to see some similar stuff, except our equation's a little bit different. It's y equals 1/2 raised to the x. Okay? We're going to type that in our y equals. So go ahead, go back to y equals, clear it out. Type in 1/2 raised to the x. Make sure your 1/2 is in parentheses. Otherwise, your x will just be on the 1 or the 2. Technically, the 2 if you were to do it in your calculator. But make sure it's on the whole 1/2. So make sure 1/2 is in parentheses. And then when we go into our table and we look for -3, we're going to see that it's grouped with 8, 4, 2, 1, 1/2, 1/4, and 1/8 if you turn those decimals into fractions. And so you guys can see that it's very similar to the last one. Let's go ahead and graph it and see what the picture looks different. So -3, +8 starts up here. -2, 4, -1, 2, 0, 1, 1 1/2, 2 1/4, 3 1/8, and then we're going to try it for a nice smooth curve between them all. Arrows on the ends because they do keep going. All right, so it says that this graph would be called exponential, and hopefully you guys know that this is decay. Okay, the graph is decreasing from left to right. And again, when we talk about exponentials, we have to talk about the form being y equals ab to the x, okay, which we'll talk about later too. If I go back up here and I rewrite this to have an a value, you're going to see that our a value is 1, and that a value, again, like the last one, is our y-intercept, which you guys can see from our graph is 1. So our a number is a 1, okay? And again, that's our y-intercept. Our b value is our multiplier, and you're going to see that we're not multiplying by 2 this time. We're multiplying by a half to get it to decrease. And so our b number, which is also known as our base or our multiplier, is 1/2. Okay? Our domain, from left to right, left, as this goes up, it is still going towards the left, so it's negative infinity. And as it goes towards the right, it is still going towards the right, so positive infinity. So we could also say our domain is all reals, or negative infinity to positive infinity with round. Okay? Our range, the lowest it goes is 0, although it doesn't quite reach 0. And the highest it goes is infinity. Okay, and so we'll say 0 to infinity. Infinity we know gets round, and we just talked about it up there, but we're never going to reach 0. Think about eating half your sandwich. You're never going to eat the whole thing. So we don't want to include 0. Okay? Our asymptote, the invisible line that it gets super duper close to but doesn't touch, is again our x-axis. Okay, so that's our asymptote. All right, and I will see you guys on the back side of notes for the rest of it.